Hello everyone again and welcome to my channel. On our previous video we looked at the aldehyde reaction, which involves a space movement of a particular hydrogen atom from one particular molecule to another through a particular cycloaddition reaction, where we have this particular region, which is the HOMO of this molecule, actually performing a superficial reaction or orbital overlap with respect to the LUMO of this particular molecule, which is our electrophile. Now, we're going to be looking at how this is actually applicable into our next part, which is an intramolecular reaction. And this particular case, we're looking at a terpene derivative. Now, there are actually 3 steps involved in this process. The first step is you're going from this particular molecule over here through the addition of our Lewis acid, which is zinc bromide, and thereby this actually leads to the formation of our intermediate step over here before performing hydrogenation, where this double bond later becomes a sigma bond over here. Now, the key point is going from this particular molecule to that molecule over there, and this process involves an interesting performing or reaction which is related to this previous step. Now, let's look at what is happening here. In here we have our HOMO region over here, and this HOMO region will perform hydrogen or hydrogen atom transfer to this particular part over here, thereby performing a specific cycloaddition reaction where we form a ring. This is not the case here because we don't form a ring here. However, this part here, which is an intramolecular process, forms a ring, which is what we got over here. Now, let's look at the mechanism involved in this particular process. Now, in the mechanism, we have our molecule, which is oriented in this particular part over here, and this other part, which is our in position, has a hydrogen positioned here. Now, to focus on this Lewis acid actually helps in stabilizing the transition state, where our zinc, which has a negative charge, bromide in this case, will somehow pull electrons away from this high oxygen over here, which has a positive charge in this particular step. Now, what we get is a cycloaddition process where the electrons actually go from here, which is from pi to sigma bond, then over here, and while on this other part we have our pi forming sigma bond, where this proton moves from here to this particular oxygen. Now, this other sigma bond later forms a pi bond, what we got over there. As a result, we're going from this particular molecule over here to that molecule over there. Now, let's look at how this particular molecule is actually formed in the transition state. Now, the transition state actually determines the stereochemistry, and this stereochemistry comes from all the chair arrangements at the transition state, where the methyl is at equatorial position. Now, let's do another drawing in this particular part here. So in here we have a hydrogen, which is in this position, and in here we have our carbon atoms, which forms a ring, while you have the methyl group, which is equatorial, and over here we have this carbon, and then we have the oxygen, and in here we have the particular sharp or critical bonds. These are the non-critical bonds in this case. However, the main critical bonds that are actually stabilized by this zinc bromide actually occurs in this step, where the zinc bromide is actually positioned equatorially, and then we have our hydrogen, which is actually a target hydrogen, which is also equatorial in this step over here, and this hydrogen has an interaction with the oxygen where the partial double bond is actually about to disappear, and on the other side we still have our sharp hydrogen atom over here, which is not critical for this particular step. Now we have another interaction between this carbon, which is what we have over here, and this carbon over here, which is what we're seeing in this step. And then we have an interaction which is the loss of our pi bond, which is at this particular region. And then in here we have the formation or partial formation of our sigma bond, of our pi bond over here, as a result of the loss of our sigma bond in this particular region, thereby leading to the formation of our molecule, which is chair in configuration. Yeah, and that is actual symmetry of what we got over there. So that's about it for this particular video. I hope you all are able to actually go through this step and understand what is happening in terms of the transition states over here and how this particular molecule leads to the formation of that. All the same, thanks for watching, thanks for following me through this, really appreciate it. Hit a comment down below, let me hear your thoughts, ask any question. See you all on my next video. Peace, love you all, and be smart.